Great, so we just finished the elimination method. We saw that x equals 2 and y equals 2/3. This is perfectly correct. You can take that pair x and y, and you can plug it into equation 1 or 2, and both of them should be satisfied, meaning that if I plug in 2 here, I get 2 times 2 is 4, minus 3 times 2/3, which is 2. So 4 minus 2 equals 2, right? Into the second one, I get 2 plus 2 equals 4, right? Because this is 2, because 3 times 2/3 is 2. Okay, so that's all well, right? What if it wasn't so simple? What if there wasn't a 3 there? What if it was a y like this? This makes it a little more complicated, doesn't it? Right? Okay, so we're going to do the same thing, essentially. Now we have to decide whether or not we want to eliminate y or x. But before we do that, we're going to multiply the equation by a number so that we get it in the nice form. What I mean by nice form, well, when I had a 3 here, right, 3y and 3y, that was nice because I could eliminate it. So that's all I mean by that. It's not like a technical mathematical term or anything like that. Okay. Well, in the last video, we dealt with eliminating y. So in this video, I'm going to just show you also that indeed you can just as well eliminate x. So let's take this second equation, right? And I could do it to the first equation too, but what would I do to the first equation? Well, I'd have to multiply everything by 1/2. That's not very nice. So instead what we're going to do is we're going to multiply everything in the second equation by -2. Okay. How did I get -2? Well, this is 2x and this is x, right? So I want these to match up, the 2x and the x. I want them to match up. And I want these to be opposite signs, right? So that way I have 2x and -2x. So that when I add the equations together, x is eliminated. Okay? So what does the second equation become? Okay? I'm going to call the second equation I star. Okay, the star just means I modified it slightly. Okay, so -2 times x gives me -2x. -2 times 3y, this is going to give me -6y. Okay, -2 times 4, this is going to give me -8. Okay, so that's essentially all you have to do, and now you have a pair of equations that are nice to one another. Let me ask a question, more philosophical, I guess you could say. Is the second equation any different, really, than is the new version of the second equation any different than the original version of the second equation? It's not, right? So let's think of a very simple example. Suppose you had the equation y equals x. So y equals x is the straight line, right? That goes, right? It goes like this, right? This is y equals x. Now suppose everything in this equation I multiply by 2, right? That's what we did, right? To get 2 star, we multiplied everything by a number, in this case -2. Well, suppose I did something similar to y equals x. Well, now I have 2y equals 2x. It's really the same graph, right? So if I plug in x equals 3, that's 2 times 3 is 6. So 2 times what gives me 6 on the left-hand side? 3, right? It has to be 3. So if x was 3, y is 3. So clearly, multiplying the equation, the whole equation, does nothing. Okay, so that was a little bit of a detour, but let's finish this. So I'm going to add these two equations together, and the x's are going to eliminate, and negative y plus negative 6y, this is negative 7y. And 2 and negative 8, that's going to give me negative 6. Okay? If I divide negative 6 by negative 7, I can solve this, right? So those will cancel. And negative 6 divided by negative 7, this is 6 divided by 7. Okay, and then the final step right, we had y equals 6 divided by 7. I'm just going to plug that up here, right? So plug it into 1. So I have 2x minus 6 divided by 7 equals 2. Okay, I want to solve for x. Now, I always say leave that calculator alone. Don't pick it up. Okay, so how can I make this easier to solve? What if I multiplied this whole equation by 7? Okay, right now I'm just doing algebra. Okay, so if I multiply everything by 7, I get 14x minus 6 equals 14. Now you might say, why did I do that? Well, the reason I did it is because I don't like that fraction, right? So indeed, my y solution is a fraction. There's nothing I can do about that other than changing the problem, right? But indeed, the solution for y is y equals 6 divided by 7. But that doesn't mean that I need to keep that same form in the equation, right? So I don't like the 6 over 7. I can get rid of it, but when I do, I have to change my 2x to 14x, and I have to change my 2 to 14. Okay, so let's solve for 14x, or x rather. Okay, so if I add 6 to both sides, I get 20, and so x equals 20 divided by 14. Okay, and I can simplify that, divide the top by 2, and I get 10, divide the bottom by 2, and I get 7. So your final solution is x equals 10 divided by 7, and y equals 6 divided by 7. Okay, so that's the solution for the pair of equations. In the next video, we will talk about how to use matrices to do this sort of stuff.